Hello, everyone. My name is Maz Barami from Wolfram Research. Welcome to the fourth session of our live coding series with Mitch Stonehocker. Mitch will do live demonstration of key features of Wolfram language that are very useful in building Wolfram Cloud APIs to JavaScript front end and serverless backends. For those of you who join us for the first time, Mitch has been using Wolfram language for more than 30 years. His work experience is quantitative and operational financial markets. Most recently, he has used Mathematica, Wolfram Cloud, JavaScript, and AWS to set up ChristyHealth.org and other websites. During previous sessions, Mitch focused on JSON, calling external services using Wolfram Cloud for storage and images. Today, he will discuss image aspect ratio and sizing and how they come into play with APIs. Without further ado, let us welcome our instructor, Mitch Stonehocker.
Thanks again, Mats, and welcome everyone. We are going to finish up a few of the details around aspect ratios, image sizes that we didn't quite get to in our third session. Then we're going to move on to a final project which will incorporate all of the learning that we've done in the first three sessions. Without further ado, let's get to it. The thing that, okay, so let's just start with this. What I'm going to do is I'm going to bring over the notebook that I've been using as a guide for session 3, because I rather than getting into the coding of the end part of session 3, I want to try and move through this material as quickly as possible, and also to sort of remind you all where we were at the end of session 3. First of all, for your reference, if you go to my GitHub, you'll see that I have a repository called Live Coding, and in Live Coding, you'll see that there's a folder called WL Notebooks, and in that folder, you've got 4 notebooks for each of the 4 sessions, and this will be the last session. Promise you, this will be the last session. Well, for this part. So what we're going to do then is remind ourselves that we were working on a particular equation in which we use the Mathematica solve function to get the 2 potential results from that equation. So that becomes a list of lists. And with that list of lists, we can do a couple of things with that. First of all, we can send each of the results of this list right through a piece of styling format, which is good to know, and we're going to use it later on in the body of the code. But this is just to show you how we can do that very, very easily. And secondly, now, what we want to do is we want to concentrate on how we put all of these concepts of image size, aspect ratio, making sure that given the particular space limitations that you might have in HTML and the aspect ratio limitations that you might have in HTML, how can you enforce that what we're producing in Mathematica will accommodate exactly what the requirements are in HTML, or vice versa. If what you're doing on the Mathematica side is saying, well, I need to have a certain amount of space, and the aspect ratio needs to be, H and W or X and Y, then we're telling the front end guys exactly what the dimensionality needs to be in the HTML and what to expect. One way or the other, we've got to coordinate all of this. And so there are a couple of ways that we can go about this that I have found that really streamlines and simplifies this process, as opposed to a whole bunch of guessing that you can do along the way. So as we noted as we note here, we have a list of lists, and if you put that into grid form, then what you're going to see in grid form is that there are the X left side of the grid, the X Y or right side of the grid, the Y top, the Y center, and the Y bottom part of the grid. And we're going to express how many printer points, I misspeak here, that's printer points. Printer points we want on the width of this, and what our actual width height ratio is to be what font size we want to use, and we'll just incorporate all of that into a grid first, where we're simply taking the flattened part of the equation, running it through our styling. We're putting our spacings in here according to what we've defined here. And then we're going to put a red dashed line of thickness 1 as a frame style in our grid. And then what we're going to do is we're going to put our grid result into a frame and wrap some more formatting around this. The reason why we do this is because in frame, we have an option called image size. Now, image size is not an option of grid, so we can't use image size in grid. So what we have to do then is we have to wrap our grid with frame so that we can use image size. And in our image size, we're going to use, remember, our custom functions that we created prior, which is if we know what the width requirement is, then we can calculate what the height requirement is by knowing what our printer point width is and then knowing the aspect ratio parts. All right. So what we're doing then is we're not guessing anymore what these dimensions are. We're calculating them explicitly, and we're using that. Now so in other words, we're creating the image size exactly to be the size and dimensionality that we want. We're doing that using our framed, and we're styling that to be in this case, a solid red line. And then we're wrapping the frame with rasterize because it turns out that frame returns back the head of frame. It doesn't return back an image or a graphic. And things that go into when we want to send images, graphics over to HTML, it has to be an image. And so rasterize does that. And so we wrap frame with rasterize, and we tell rasterize exactly the dimensionality and the number of pixels that we want to have for creating this actual image. And so if I create all this, hopefully I am not missing any priors here. Okay, that seems to be running. All right, so, whoops, sorry. This is the output of the grid, and you can see that it is outlined is outlined in dashed red lines. This is the output of the framed object, and you can see the solid red line around the dashed red lines. And this is the rasterized image object, and we have the heads down here. The first one is a grid, the second one is framed, the third one is image, and we have our dimensionality here, our aspect ratio, etc. here. And so this is completely ready to go now into our API making functionality. And the way that we're doing that is, you'll remember that we have created this ability to define the arguments, define the function, define the format result, pass some test parameters, create the test parameters, define the endpoints and the function names and the authorization, and then we just pass it through our make API function and our cloud deploy function, and we're off and running. Now, I'm not going to run that right now because I already know that it works. And the reason why I know that it works is because that's what this API is. This is calling now this is the API in the JavaScript. And you'll remember that's inside our image tags here. And so the purpose of having these controls here is so that you can start, we can start to play around with this. So, for example, right now this is set to a 2-inch, well, not quite a 2-inch, it's actually just 200 width. And if we were to make that 400 width, then you'll see exactly what happens. The big red box around here, the outside red box, which is really the frame, the outline of the frame, right, is this. If we wanted to change the spacing inside the grid, so 2 on the left, 2 on the right, 1 on the top, 1 on the bottom, 3 in the center, then you see how we're changing the spacing of the grid that's going on here. If you want to change the font, then we're changing the font. And if you wanted to extend change the number of rasterize, the number of pixels, i.e., you're increasing the raster multiple. That's one way to go about it. But you can also do things like, well, change the aspect ratio by changing the height and the width component to this. So now you're a 1:1 aspect ratio on all of this. So it's all of these kinds of variables that go into managing and controlling exactly the kind of image that both Mathematica is producing and what's being sent to HTML, so that JavaScript and hence HTML can display it in exactly the way, and it looks pretty good. I mean, it's pretty sharp, crisp, etc. Now, there's one other thing that I wanted to get in here before we get into our final project, and that is the use of controls. The use of controls in an HTML form that is managed by JavaScript relative to the passing or the use of APIs. Now, in the earlier APIs that we're using, where it's explicitly a form, right, it's the click of the button that manages both the inputs, the fact that there are inputs, and how the URL used for the API call is put together, and then how that API is actually handled. So absolutely everything about the form and the utilization of the API is effectively under the control of this button. All right. So that's not true in images necessarily, or it doesn't have to be true of images. And so you can make your images extremely dynamic. So for example, all I have to do is change the value of a field here, and you're seeing that the API is being called immediately. There's no button clicking going on here. And so if we were to go, and so think of what some of the side effects of that can be. So for example, if I wanted my base pixels to be 200, but I was very slow at entering 200, what you can see is, oh, I don't actually have an image back yet. Oh, but now there's an image that is 20 base pixels wide, and now, oh, there's the 200 thing, right? But and now we're going to have to change our font size in order to accommodate the font size inside the pixel width that we have allocated for ourselves. So what you're starting to see here is that these controls are connected to the API in, I'll use the JavaScript method on an on-change way. That is to say, any change that happens in this form is immediately being submitted via the API to Wolfram engine, to the Wolfram cloud to kick off the process of putting the API result together and then sending it back. All right, so all of that's happening very dynamically in the back end. Now, this, like I say, this can have some not so good side effects. So again, so for example, if I wanted the 300, but I'm just too slow at typing 300 here, then you see how that can have an effect on what's going on to the API. In other words, there were 3 API calls made there, and that may be exactly what you want, but it also may not be what you want. So I tend to break things down into controlling the inputs such that anything that was a text box input or a standard HTML type input, anything that is along these lines, I like to control them via a button, so that you don't have these side effects in which the API is being called on an on-change sort of tempo, right? However, there are a lot of form control objects that are Boolean, for example. It's true or false. It's a one, and even though this checkbox has an on-change method to it, the on-change is going to be true or false, on or off. And even when you do things like have a drop down or select boxes, right, where you're only going to be selecting one item, even that is completely fine to have a buttonless API buttonless API connection to your API, because again, you're in sufficient control that you're not going to get multiple API calls to retrieve this image. So this is a side effect of dynamic images. There are a lot of ways to do images, but when you do dynamic images, which is effectively on every on change, you're calling the server to update what that image needs to be in HTML. And these are just some of the considerations in the design and the performance and the control of the web page that you're going to want to be involved in. And it's nice to know that on the computation side, on the Mathematica side, it'll handle whatever you're going to be sending. It's not a problem. All right, so now what I want to do is I want to change gears, and I want to actually create a little bit of a project. And this project is a harbinger of some work that I'm going to start doing with Wolfram U, in which what I'm going to do with Wolfram U is put together some actual self-paced project kinds of sessions where all the code of both Mathematica and JavaScript and any other code that's going to be used is part of the project, including setting up a complete JavaScript and, in my case, React, including the React libraries. And in subsequent sessions, we'll be getting into Node, so we would go through the process of setting up a Node instance. And so we'll go through all of the detailed steps of getting an environment set up and running on your machine so that you can run through all of the code needed in order to accommodate a project. So this is just a little bit of a sort of dress rehearsal. So one of the things that I'm going to do in this project, though, is I'm going to be using Wolfram data bins, and that happens in bin drop. And so if you just go to datadropwolframcloud.com, then you will be able to get and sign in, et cetera, then you will be able to get into your data bin as long as you have an account at Wolfram. I'm pretty sure that you already have this, whether you know about it or not. And so you can just click into your data bins, and this is the data bin that I've already created for the little project that I'm going to run through. Already has a little bit of data in it, so I'm not going to bother creating a data bin. I'm just going to show you how you would go about creating a data bin if you wanted to from the Wolfram, and that is to simply create a data bin. And one of the things that you can do is name the data bin a name that you want, and you will have to set permissions on it. And in this case, I have set permissions to be public. And then what you can do once you've created a data bin is you can come in here and say, well, I want for all of the data bins, I want to create a data set where I have a key called short ID, and that's extracting the short ID out of the data bin. Or I have a key called name, and I'm extracting out of the data bins the name. And then I want the actual data bin. And the way that we can get that, what then returns on that is, in fact, I have 3 data bins, all called readings. I need to delete a couple of these. Some of these were old tester, beater upper data bins. So not to worry. But what you can see then is you've got a short ID of one of the data bins. This is the data bin that we're going to be using. And of course, it's really interesting to sort of get in here and see that, for example, there's all of the detail about the data bin that you might be interested in. So then what we can do is we can say, well, of the particular data bin, whoops, I think I already did that. So let's not do that. Okay, this is where sorry, I was getting a little bit ahead of myself, or a little bit, ahead of myself. All right, so what we want to do then is this is a way, right? Using data bin add is a way of quickly adding, for example, a reading to the readings data bin here, right? So if we run that, right, then it's as easy as that. We just added a new reading to the data bin, and what we've done is because data bins can be created into a data set once we've loaded it into a Mathematica session, then I want to put it into a particular order. And the way that I want to do that is I want to, in this case, there are only two keys, reading and timestamp. But what I want to do is I want to actually sort timestamp in reverse order. That is to say, I get the most recent item timestamped, and of course, I want the reading associated with that timestamp. And so this is the way that I would go about it. First of all, I want to extract readings and timestamp, and I want to reverse sort by the first item of readings and timestamp, right, in terms of absolute time. And that's what I get here. All right, so that works just fine. We're going to be using that as part of our project and in as we go along here, right? So then what I want to do is I want to be able to create a time series from the readings data set that we've defined above. And in the time series, I want to be able to extract out from the data set, I want to be able to extract timestamp and readings again, but on timestamp, I want to convert that into a date string. And I want to create that into a time series object, a Wolfram time series object. And so that works just fine. Okay, so you can see what I'm doing is I'm going through the process of starting to put together the pieces that I know I'm going to need in working with this data. Now, the next thing that I want to do then is given that I now know that I can create a time series on readings, what I want to do is I want to apply date list step plot on the time series that we create in all of this. And what I want to do is I want to put a dot on the right element and mesh full. And then I want to make sure that I understand what the head of this thing is. Let me do that. So if we do that, okay, yep, that looks exactly like one of the pieces that I'm after for our little project. So I guess I should have done a better job of explaining what we want to do. What we want to do is we want to incrementally add readings where we are giving ourselves a timestamp when we acquired the reading and the actual reading itself. So what this is going to do, of course, is going to create a time series of readings. And what we want to be able to show is the current reading in some sort of graphical way. We want to show the time series of readings in some graphical way, and we want to be able to show a table of, the first or the most recent 5 or 6 or 10 or whatever readings that we want. What we don't want to do is necessarily return this entire table, because as you can imagine, over time, that's going to become a very long table. So we don't want to return the entire table to the HTML, but we want something that is that is going to show us the most recent 5 or 10 or whatever. So this date list step plot is going to do for us exactly what we want. It's going to show us the full-on time series of everything that has been added to this readings data set so far. Now, what I'm going to do to represent the most current reading is an angular gauge in which we're extracting out the first reading. And when I say the first reading, remember, I did a reverse sort so that I know that when I come into this data set, all I have to do is pick off the first item because it's already been sorted. So we're taking the first item, the first reading, and we're just putting it into an Angular graph. And we're going to play around with the formatting on this Angular graph, and the formatting of this time series graph a little bit further on as we go through this. But this is just to get it working first. So I know that I can do what I want to do. So we're just stepping through this project a little bit. All right. Now at this point, I know I have the 3 pieces that I actually want to work with. I've got a data set or a table. I've got the time series, the full time series of all of the data in that table, and I've got the Angular graph, which is showing me the most recent reading. So how can I mock this up to sort of get a sense of how this might look on the HTML page? Well, the way that I'm going to go about it is I'm going to put everything in a grid, and I'm going to put frame around it, and I'm going to use align center. And you can see that I already have named this angular grid. I already have the readings in a data set, which is tabular enough for the kind of working up, mocking up that I'm interested in. And I already have this date list step plot. So let's see what that looks like. Okay, well so what that's telling me is in an HTML, I've got something that is not so high, but quite long. All right, so that might work under certain HTML constraints. All right, another one might look something like this, where I have the two graphics over on the left side, the most current reading, the time series, and a longer list of table readings over here. So if having a longer list of table readings is really important, then this might work really well if we've got sufficient sizing and spacing over in HTML. And then, of course, the other thing that I always like to try and do is over in HTML, of course, things can be flexed. I haven't at all spoken about this, but one of the things is that screen sizing can impact, right, exactly how. So here's the for instance. You see in this grid, in this form grid area, right, all of these controls are packing up and unpacking in particular ways, right, depending upon the dimensionality of the screen. Well, this flex capability is really important to once you start to really get into the details of this, is really important to understand how things sort of pack and unpack depending upon whether you have whether you're looking on a wide and thin screen, whether you're looking on a regular, laptop screen or a monitor where the browser is completely spread out across the screen, or whether you're looking on some cell phone device right, and whether you're able to flip it around and et cetera, et cetera. So this is another way of looking at if the screen dimensions are really flexed up, how or really pushed in, how this set of three things might look in a cell phone kind of. So anyway, it's just to get the idea of the kinds of dimensionality, the kinds of spacing, the kinds of viewing that might happen for us. Now, the next thing that I wanted to test is just getting at some of the styling that we might be able to use on, for example, the keys. So we've got our data set. We know that we want the keys for the first item, and what does the styling look like that? And of course, the styling can look like whatever you want it to look. In this case, I just have assigned a font family, a size, and made that bold. And so what we can then do is start to look at, well, if I want to really stylize, so number one, why am I going through that exercise? Well, I'm going through that exercise because this data set object is not going to translate well to HTML. It's just not going to do it. So what we want to do is, there's a couple of decisions that can go on here. In the way that I'm going to proceed is I'm going to put all of this information into a grid, or at least I'm going to put into a grid form the information that we're going to send back to the HTML. And then we're going to rasterize it so that it becomes a part of a single image. The single image is going to have the three components to it, where the grid output of this data set is also an image. And so what we're going to have to do is extract out from this grid everything that we need in order to rasterize the entire thing so that it can be sent on as a single image with the gauge and with the time series plot. So the way that we're going to do that then is, okay, that seems to work. And all we're doing is we're using what we've used up, what I've already shown up here, is we're stylizing all of the elements of what we're returning in a good way. So, for example, you can now see that if we just wrap grid around that, that's how that's going to look in a grid. Well, okay, that looks good to me. You can obviously change any of the stylings that you want in there, but I now have a way of completely stylizing the 3 or 4 or 10 rows of a data set in using grid and being able then to apply the rasterizing process, the framing and rasterizing process to create exactly what we're doing. Now, so let's do that. So here what I'm going to do is I'm just taking this piece of work here, which I now know, we now know that it works, and we're going to copy it in here. And then beyond that, we're just going to add in here all of the styling and the framing and the spacing that we're going to need around grid to be able to get this to produce exactly what we want. And we're going to create a function that manages this entire process for us, okay? So what that means is that if I wanted to return 10, okay, there it is. If I had a different, notice, if I had a different data set, and then so long as the keys were the same, then I would have exactly the same sort of functional output of this. Now notice that the head of this thing is grid, so that's not ready for us yet, right? We can't pass grid over to HTML yet, but we'll solve that in a minute. Okay. And the way that we solve it is we solved it in exactly the same way as we solved it in the review that we went through just a few minutes ago. Is we're going to wrap frame around our grid, and now we're going to apply the exact image sizing that we want for our grid. And because we're still on the Mathematica development side, we're just going to add in here the red style, and we're going to make sure the margin frames are 2 and etc. And we're just going to see how that works. All right, so with this margin frames of 2 is exactly where this little space on both the X and Y dimension around the grid is coming from, right? So if we were to set that to 0, you see what happens. Whoops, why didn't that happen? Not sure why that didn't happen. I thought that would have happened. All right. Oh, it's because I've got the grid. It's because I've got the spacing up here on the grid. All right. At any rate, we've got the image size around here that we're after. We're using the function that we have. We know that the printer point size is 225 because we know that on the width, and we know that the width printer point is 225, and we want the aspect ratio to be 16 by 9. That will automatically calculate the height printers points that we need. So we're good to go on that. And so what we can do now, we know what we can do now is we can rasterize that, and that will become an image. Now we're going to not go there quite yet because I want to start working on the gauge. And the way that I'm going to start working on the gauge is I want to create some colors, some color indicators to the gauge, and I'm going to do this in a fairly arbitrary way. Is I'm just going to create a couple of range increments here, some range points that are incremented by 10 points to create a list of start and end points. We're going to wrap an association. These will become the keys to an association of colors that we're going to send onto this. And the list of colors that we're going to be using is here, so that when we run this entire thing, this is exactly what we have. So this is a pretty interesting way that I like to use associations, where the association in this case is a range, which is pointing at a particular, in this case, a color. So I know, so you think of lookup dictionaries, right? So this is the thing that I want to look up, and what do I get? Well, I get that color. Or, this is the thing that I want to look up. What do I get? Well, I get the color yellow. Okay, so that's all good, and that is kind of also actually interesting that you can kind of go in here and start playing around with some really interesting ways of defining colors. But not to worry, we won't. That's for someone else's live coding session. All right. So anyway, so now I think we're ready to put together our gauge function, just like we have our grid function. we're going to create our Angular gauge function. And this only takes one reading, the reading that we want. And we're going to restrict the gauge to a range of 0 to 100. And of course, what we're going to be doing is there's a option on gauges in general, but Angular gauges for scale ranges. And that's where we're going to put this piece that we tested up here. So we wrote the code, tested it. This is producing fine. It's producing in exactly the form that scale ranges is expecting. So we know that this is going to work. And the rest of this is just sort of formatting kinds of considerations. Like, what do you like? I like this class selector face element function, and I like light blue, and so when we run that, this is what we get. So we are returning a result 62. So not only do we get the needle pointing at the 62 area, we also get the number 62. And of course, we have our colorized ranges here that are ready to go. So that looks good to me. I think that's just fine. Now what we want to do is we want to work on the date list plot. And this is pretty straightforward. We're going to create this function where all we're doing is putting our data in. And you'll remember from what we did earlier, all we're going to do is drop in here a particular, all we have to drop in here is a time series. But of course, date list plot, you can look at help, et cetera, to see the forms of data, the types of data, and the profiles of the data needed for a date list plot to step on, or to operate on, excuse me. But then what we're doing is I'm adding this right point. What this is doing is it's saying, give me show me the position in which a data element is in the plot, and I want that to be, meshed across all of it. And then here's our image size for it. We want the plot range on the x-axis to be everything, so all of the time-stamped elements. And we know that we're between 0 and 100. That's just how we're doing this. But that you could set the y scale to be anything you wanted to, of course. And then what we're going to do is we're going to set a range for a frame. We're going to label the frame, and we're going to indicate some grid lines, and we're going to style the grid lines to be dotted. And once we run that, let me just bring this down here. Once we run that, you see that's our output. So you can see that the data input is simply going to the data set, and it's saying, give me all of the timestamp and reading. That's the data source that's coming in through that argument there, and date list plot is doing all the rest, including the y-axis, the x-axis, the time dimension along the x-axis, the grid or the framing, the grids, the plot label, etc. So that all looks good to go. Now, what's also good, the way that we did this, of course, is we have a function now that is managing everything about the three components to our API return function. So, trying to make sure that we're developing everything in a modular way, and that when we start to put all of the pieces together, everything is its own modular component, so that if anything breaks, if one of the pieces of what we're putting together breaks, then we know which one to go back to and figure it out. All right, so what we're doing then is we're putting together the outer frame, the outer rasterized frame, right? Because we're going to rasterize this entire thing. And so what we're doing is we're putting everything inside, we're creating a list called items. That's one of the parameters. We're going to put in our printer point width, how many times we're going to multiply for rasterizing, what our height and width is, what is the format whether or not we want something framed, so that's a true or false, and then what the items are. So what you can see is that this items is a list. Items is going to be have grid wrapped around it, and then we're going to frame everything, and we're going to image size the frame. We're going to image size to rasterize. We're going to tell rasterize how compactly, if you will, we want the pixels to be, and then what we're going to do is we're going to put these pieces together where items. We're going to define items as, and we're using our functions. This is the gauge. This is the grid. This is the time plot. Here's the list here's the arguments, right, for our function here. And if we've done this right, there you go. So this is what we're going to expect to see in HTML. All right. Now, because this is all rasterized, actually, what we can do is say head. Because we rasterize that, this is an image. Well, we know exactly what to do with images. We've done that several times before. And so now we are at the point where we're going to put together our API call, because we have all of the components that are going to go into our function block. We have all of that completely mapped out, and all of that is managed by this function. Okay? So pretty slick. So we start off with our arguments, and what we're going to take from our arguments is a input from the API called reading, and another input called rows. And reading is going to be the number that we're going to enter in HTML. And if we're looking ahead a little bit, right, we're going to enter a number here as readings. And then we're also going to enter how many rows we want back. And then we're going to click a submit button so that this becomes a controlled object. It would not be fun, right, if the reading that I had was 99 and I entered 9, oops, right? Because what happens is, because this is all happening on an IMG tag, that API in an uncontrolled way would be kicked off right away to Wolfram, and that would actually be entering a reading of 9. I'd get back a gauge that reads 9. The last timestamped item would be 9, and the time series over here would be 9, and that would be unintended, right? Because I wanted to put in 99. So this is an example of why we have to be able to control the user input here, and you can see that this is actually a dead submit button. I've killed it because it's still expecting more inputs. Or killed it. I disabled it. All right, to use proper coding language. All right, the next thing that we want to do then is we want to build our function block. And in our function block, what we have to be able to do is we have to be able to pass the data bin ID, right? And so the data bin ID is going to be used right here to go call the data bin. And so we're getting the data bin into this thing called readings, and you can see what we've done prior, right? What we're doing is we're reading into a Mathematica object called readings from our data bin. We're using readings to pass in the readings argument that we're receiving from our HTML, or excuse me, from our URL from the API. We're associating that with the key readings, and we're doing a data bin add, which gives us this readings data bin, which we are then creating into a data set. We're reversing all of that data set in the way that we did prior. And then we're using this data set down here in our items section, okay, so that we can pass items to our constructor, right, our output. So hopefully you see exactly what's going on with this function block. And thank heavens above, we've done all of this function creating up above because you can start to see how much code would have to be put into this function block had we not created these functions, these modular functions up above, which gets me to one of the last final points that I want to make. Well, actually, I'm just going to say it. It turns out that so long as this argument, and this is something that you're going to have to pay attention to as you get more and more into this, so long as this module here is in memory, then it does not have to be called explicitly inside. It does not. The function does not have to be created and then called explicitly inside this function block, so long as it's in Mathematica memory when it's used down here in the function block. Now, the way to see that is to go into your Mathematica sessions. If you go into the files, let me go in here to the live coding into here, and I'm just going to pick up, let's see, this random integer. You can see, just for the sake of brevity, you can see that what Mathematica is doing is Mathematica, or Wolfram is creating for you this entire piece of code that is the API that's happening. And what's happening is this code is constructed through this process. As this code is constructed through this process, everything about that component, that module, that piece of functionality is included in here. Yeah, I'm going to let you prove that to yourself. That's exactly what's happening. At any rate, so the final thing that we need to do here is add make sure function and function. Yes, okay. Let me close that off just so that I'm making sure that I am where I am and I'm not kidding myself. Okay, so what we want to do is we want to return this as SVG format. Okay, so now what we want to do is we want to include a couple of testing parameters. One for the reading, and we'll say 53, and we want to return the number. We want to return 6 rows, and let's see if we put this into our API maker function, whether or not we get something. I could have closed that off, that's for sure. And it looks like 53, 53, 53, and it looks like 53 is right. So that seems to work. Let's just test this one more time. Let's say 96, and that is 6 rows. Yeah, okay, 96, and let's return 4 rows this time. Okay, 4 rows, 96, 96. That okay. It looks to me like we're ready to cloud deploy this now. All right, so you remember the functions that we have for cloud deploying. All I'm doing here is I'm putting this into the same old endpoint that I put everything, live coding, and I'm going to call this function name grid gauge. I'm going to make it public. Oops. Let me actually include over here the make cloud deploy function. Okay, that should work. And let's just do this. Let's create a session. We'll do a web execute into a Chrome browser. Let me move this over here. And there we go. Nice. So let's just test this in the Chrome browser. So let's say, yeah, 6. And let's say 6 rows again. Let's see what happens here. Okay, 6, 6, 6, and way down here to 6. Looks to me like it's working. Now, over, I can close this, close that, and over in our web page here, let me go over to API 11. You can see that we have the form controls for the reading, the form control for the number of rows. Here I have a button, and you can see, if you're familiar with this kind of syntax, you can see, first of all, I have a disabled if. That's how you can read all of that, right? So I have a state object inside this component that is called isLoading. I have state objects for reading and rows. And if any of those things, and I don't know how familiar any of you are with JavaScript, but there's this notion in JavaScript of truthy and falsy. So if any of these things are truthy and or falsy, then based on this logic, that disabled will be true, disabled, or false, not disabled, right? The same kind of thing happens here, where loading is either truthy or falsy, and if it's truthy, then you get a submit on the button, or calling Wolfram Cloud thing on the button. And if everything works out, then there's some more logic down here, which if all of these things are truthy, then show the image tag. If it's falsy, then enter reading. And you can come over here onto the screen, you see, well, there's enter reading, which is saying, well, there's something that's falsy about this, so it's showing enter reading. All right, well, what's falsy? Well, what's falsy, of course, is I've not entered a value in reading. And because I wanted to be able to show you that unlike this example here, where I have no button controlling any of the components of these form objects, here I have a button which is explicitly controlling the form objects. And in fact, I have a piece of state object which is called API URL, in which case, when the button is submitted, right, all of the pieces of the API URL are constructed and are set to a piece of memory state in the component called set API URL, so that becomes truthy, i.e., it exists now. And what will happen is this will become truthy, and that URL then is then passed via this SRC component and will generate the image. And so if I'm going to say, I'm going to say 35, and I'm going to submit that, and in short order, there we go. And so what do we see here? We see 35, 35, 35, and a lot of things have been crunched together in a very short period of time. So, but it looks like that's 35. And so, voila, we're done. Now we've put a lot of pieces together here, right? We have created a data bin, so we have a data store, and that data, while the data bin is a Mathematica thing, it's a Wolfram thing, we are going outside of the API to go get the data. We're operating inside the function block on the data, creating various graphics, putting together a table. We're saving that data back to a data bin, so that the data bin, we're not losing track of the fact that we had a 96 and a 6, and these were the timestamps, right? So all of this is continuing to update as we go along. And so we've completed a particular a pattern that is frequent in, the computational world, is frequent in a lot of different use cases, which is data goes in, it's part of it needs a timestamp associated with it. It's time-stamped, and you want to have information both about what the current state is and what the state has been over time. So I have to say, I'm not a bit surprised that we finished this today. And this, in fact, wraps up the 4 sessions. And if you've missed any of the prior sessions, then please go ahead and wrap them up. And like I say, all of this code, both the Wolfram code and the JavaScript code, is available in my GitHub. So you can just drill down into this and see any of the JavaScript, see any of the Mathematica code. If you don't have a Wolfram desktop, then just go to Wolfram Cloud, sign up. There are free tiers, and you can load the notebooks into your Wolfram Cloud and start playing around with it. But I'm willing and open for any questions at this point.
So we have one question from our users, Daniel. He asked about bug fixing. He has created an API that runs perfectly on his computer, but gives some error on any other time that he runs on Wolfram Cloud. So, do you have any effective bug fixing procedure?
Well, I have a series of steps that I go through to try and narrow, where a bug could be coming from. Unfortunately, of course, bugs can come from anywhere, and when you've got something as complicated as what we've done here, right, it can be hard to pick out where a bug is coming from. But what I would do, if for instance this didn't work the first time, then I would just start taking out pieces. Right, I would just remove that and see if the table and the data list plot worked, and if that still produced a bug, then I would take both of these out and just see if the data list plot worked. And if that didn't, still didn't work, you see what I'm trying to do is to find a bug, you have to know that it's coming from a place, and then to dig deeper into that place, right? That's I guess from a high level at this point, that's would be my recommendation. Happy to take it offline though, because I have absolutely bumped into cases. In fact, I didn't even show this. I had this on my radar to show as a potential gotcha. But one of the things that I do, especially when I'm in, do I have it in here? Or is it in my number 3? One of the things that I know is that there can be times, you see, Mathematica knows this X as a symbol, and Mathematica knows this X as a string. And there are reasons why I stringify things like this, as opposed to just create a rasterized object on this thing. And that's because there can be, from whatever source, from whatever reason, if X is a symbol and I've somehow used X somewhere, or if some module of something has used X somewhere, then you can see there can be conflicts, and it might take a really long time to figure out how or why that thing got conflicted, but there can be conflicts. So I, as a matter of course, do things like rule replace on variables inside this to generate strings inside of here. That's just one of many potentials that you can run into when you go from the point of creating images, when you want to create an image on something that is absolutely not an image, right? And how to go about debugging it. You have to make sure that everything about it is really pristine and clean.
Mm-hmm.
That helps.
Since there is no more question, I think that's a very good point to wrap up in our today's session. Thanks, Mitch. You are watching the 4th live coding session with Mitch Stonehocker. You can find the recorded videos on the Wolfram YouTube channel. You can interact with Mitch directly through Wolfram community. Thanks for watching and have a good one.
Thanks, everyone.